Good evening, everyone. Welcome to the Aquarium. I'm Jerry Schubel, and it's great to see all of you here this evening. I want to acknowledge our sponsors before we begin, the Long Beach Westin Hotel and the Gazette newspapers that make it possible for us to bring people like our speaker this evening here from all over the country. You're going to hear tonight from Professor Orrin Pilkey. Orrin and I have known each other since sea level was much lower when we first met, wasn't it? We won't put it, but many decades ago. He's been at Duke University for 40 years, been there even longer than Mike Krzyzewski, the basketball coach. He got his undergraduate degree from Washington State, master's degree from the University of Montana, and a PhD from Florida State University. He spent several years at the Sapelo Island Laboratory in Georgia, and then went from there to Duke, and he has been there ever since. And he's a professor emeritus now, the James B. Duke Professor Emeritus in the Nicholas School of the Environment. He's received numerous awards over the years, including the Shepard Medal, which is named after Francis Shepard from Scripps, and we have our distinguished guy from Scripps here, Wolfgang Berger, for excellence in marine geology, and the Priestley Award, and he's had public service awards from a number of geological societies. He's published over 260 technical papers, and he has edited and or written 40 books, the latest of which is The Rising Sea. There are copies in our gift store, and we want to have one autographed. If you were only going to read one book about sea level, this is the one that I would recommend. I think it really is quite a remarkable book in terms of the scientific coverage, the courage with which he deals with some of these issues. And one of the things that has always characterized Orrin is he's an iconoclast. He has always been able to have the courage to speak out on issues like sea level rise and why we should retreat from the coast decades ago, before most people even were willing to acknowledge, at least publicly, that there is a problem. And he continues to be a very vocal and effective voice in getting people to understand that sea level has been rising for a long time. It's going to continue to rise, and we need to have a systematic way of dealing with it that is some combination of strategic retreat and figuring out those few places where you can stand and fight and protect some of these areas. I'm looking forward to hearing Orrin's talk. He always gives a great talk. Please join in welcoming Professor Orrin Pilkey.
This is just to show you what our problem is. This is a 1960 photograph from a small fishing village in Spain, and this is one in 2000, from the same spot, taken by a friend of mine. And this says, I think that says quite a bit. Don't have to explain that one. This is in the Gold Coast of Australia. This is an 85-story building a half block back from the beach. Problem with these buildings on sandy coasts, particularly, is that what are you going to do? You can't move that building. You could, but it's obviously too costly. It's actually 85 stories plus or minus 2. It's hard to continue to to count up a building like that. And this is a little bit of societal madness on the Florida shoreline. This up here, you can see this building is being built beyond the high tide line, and I mean it's really crazy. Of course, the beach is a nourished beach, an artificial beach, put in at some considerable cost. All over the world, we have the implements of war that are on the beach now. We have the implements of war in Normandy. This is an 8-inch gun that was protecting the capital of Mozambique, and the channel that any invading ships would have had to come in was only about 300 yards away. And any of you know anything about naval warfare, you'd know that at 300 yards with an 8-inch gun, you would not have to consider the Coriolis force. And this is a photograph taken on a typical misty, rainy day on the Olympic Peninsula. This is Washaway Beach in Washington. And each of those pipes is a water pipe that used to connect a house to an aquifer. So you can see there are 4 houses. This shoreline here is eroding at about 100 feet a year. But in Durham, North Carolina, in the Durham Morning Herald 10 years ago, I read an article just about that long about Washaway Beach, Washington. It said the night before the shoreline had retreated 1,000 feet. And I thought, wow, 1,000 feet. And it wasn't even much of a storm. So I did some looking into it, and this is what happened. This is a slump, and this is a way some beaches retreat under very high rainfall conditions with high tidal amplitude than when you have a deep channel right next to the beach. And if you had been on that beach here, you would have been part of the geologic record. So you don't want to be on those beaches. Now this is the Comfort Inn in my territory in South Nags. Had photographs taken 2 years ago, and there are four of the rooms are out on the beach. And this is a picture, taken 2 weeks ago, and now there are 8 rooms out on the beach. This motel is still operating, so you can get a marvelous view of the sea. But you want to make sure you look at the weather forecast, I would say, before you go here. The swimming pool used to be where all this stuff is. On the East Coast, we've had a number of communities disappear, which are in part due to sea level rise, in small part due to sea level rise. Always it's a storm that takes it out. Always a storm does the actual destruction or the removal of the community. Eddingsville Beach, South Carolina, really fascinated me because nobody in the area, including me, knew about it, and until somebody, a local historian, wrote a book about it, and it had just been forgotten. And it was a really important community just before the Civil War for the wealthy of, it was not a working community, it was for the wealthy of South Carolina and Charleston to come down and spend the summer. And there is one drawing that has survived. It shows what they typically did on beaches in those days, strolled up and down the beach in formal clothing. Nobody would swim, for God's sake. And here's what Eddingsville Beach looks like today. And it is a barrier island that is, this is the island part from here to here, and this is the beach from here to here at low tide. And so the low tide beach is wider than the island now, and the arrow over here is where Eddingsville Beach is now, all along here somewhere. And you walk along here and you find a lot of bricks and stuff like that. What's behind this? Well, this is one way to draw the CO2 curve that makes it look rather spectacular. Also, it doesn't show a lot of the noise that should be there, and also it doesn't show, it gets fuzzy back in here, but this is for real. This is what CO2 on this scale looks like, the increase in CO2 post-industrial increase. This is the temperature curve. Now, the temperature curve, we argue that if you want to know about global warming, you shouldn't look at the temperature. You should listen to the Earth, and I'll show you that, what I mean there in a minute. But one of the problems we have here in some of the skeptics and deniers is that they say that 1998 curve here, point was the highest, was the warmest of all, and it's been going down since that time. But that's not true. The 2005, depends on whose data you use, because these are not easy data to get, by the way. This is not easy to get a global temperature. But the 2005 temperature is probably very similar, very much like 1998, which is this point. So it is not going down. It's a very, very noisy curve. But you can consider all these things. Read the Earth, don't read the thermometers. Look at all the things that are happening, especially the shrinking mountain glaciers, which are so spectacular, and the melting of the ice sheets. And we're getting more and more reports just in the last 5 years of really accelerating melting of both the Greenland ice sheet and the Antarctic ice sheets, plus the shrinking permafrost and so many other things are happening. This is the big picture of cooling, of what's happening to our temperature. We start out here in what some would call the greenhouse Earth, and down here we get into what we call the ice house Earth. We're now at a very cool part, a cool point in the overall temperatures of the Earth. And this data back here is indeed quite fuzzy and indeed quite speculative, but with a number of lines of evidence that's probably at least of the right order of magnitude. And all of these bumps here, each of them are very interesting in and of themselves, but I won't get into that. So from now on, we're talking about things that are happening down in here. The tide gauge curve. Tide gauges are showing sea level rise. Tide gauges are the only real record we have of sea level rise that goes back more than 100 years. And tide gauges are pretty fuzzy too, because if we include the tide gauges up in the Antarctic, or excuse me, up in the Arctic, a lot of them are around Norway and Denmark and so forth. The sea level is actually lowering there as the land is rebounding from the ice. And if we, and then there are other places where the sea level is, like in the Mississippi Delta, where the sea level is going up 4 or 5 times faster than the rest, than the average of the Earth, because of subsiding, sinking sediment. And so this is one interpretation of the sea level curve. I think there's no question it's accelerating. I'm a little bothered by this point where we start at a low point and go up, because that's kind of what I just complained about the skeptics using in the temperature curve, where they start with the 1998 high point and go down. But the thing that makes that number seem reasonable is the fact that it's the same number we get from the satellite measurements, which all started in 1993. So it looks like it's for real. It looks like that curve is for real, although this is very short term. But other lines of evidence, though, all over the world, if you open your eyes and don't use a thermometer. This is from a postcard in Germany, from the Frisian Islands of Germany. I don't think you'd ever find this postcard in the U.S., but it shows a shrinking island. Now, these are different scales, slightly different scales, but I think you can see that between 1969 and 1989, this island, which had no seawalls at the time, has shrunk considerably by erosion on both the back side and the front side. This is exactly this is in the Frisian Islands. Same thing's happening on the outer banks of North Carolina, and on some other barrier islands that are on coastal plains that are not held up by seawalls. And so if an island which is several thousand years old is shrinking, that means that something's happening right now, because it couldn't be doing this for very long, or the island wouldn't be here. And what's happening right now, I think, is the sea level rise. And these islands are thinning because islands are capable of migration. That's another story in itself. But in order for them to migrate, they have to be very thin. So I guess I'm giving islands a humanity that maybe they don't deserve. But this is another line of evidence that Hal Wanless of the University of Miami discovered. These are photographs taken in 1949 and 1981 of a bridge abutment in Miami. And you can see what sea level rise has done. When he went back to take another photograph about 10 years later, it turned out that the species on the bridge abutment changed, so therefore he couldn't get another sea level rise measurement. This is something in Nova Scotia, but this is up there in the land where the glaciers were. So the sea level changes here have a lot to do with the ups and downs of the Earth as related to the weight of the ice and the removal of the weight of the ice. Here's something that we see it in Washington State, possibly in Oregon. I haven't seen it in Oregon, but we see it all over North Carolina and Albemarle Sound, especially up near the Virginia border, where the trees on the outermost part, right along the sounds, are dying. They're not dying from saltwater intrusion. They're dying because the sea level has risen just a little bit and has flooded the roots with fresh water. It causes the freshwater table to go up, and it kills the trees by the thousands. That's a good evidence of sea level rise. This is the biggest sea level rise in the United States. This is where the sea level rose in the southern suburbs of Houston. Sea level rose 8.1 feet since 1950 something, and this was a development that had 350 homes and room for another 150. And this oil refinery back here was pumping water out of a formation that was shrinking as the water was taken out, and as a consequence, the land sank here. So now they have now taken out all the concrete, all the streets, all the street lights, and all that stuff, and now they've made it into a park. One of the problems is the shrinking of the ice. The U.S. Geological Survey took a bunch of photographs of all the ice, all the glaciers in Alaska that end up in water. And this is the Muir Glacier in 1941. This is the same glacier in 2002. Look at that mountain back there. See, there's the tip of the mountain, and you can see, so a large amount of ice has been lost. But if all the ice in Alaska, all the glaciers in Alaska melt, we'd probably have around 2-inch sea level rise. If all the mountain glaciers of the world melted, and the number is kind of fuzzy, but probably 1.5 feet to 2 feet of sea level rise. But the big players, the 800-pound gorillas, or whatever you want to call them, are these. This is the first of them, the ice sheet. This is Greenland, showing the advancing of melting between 1982 and 2005. Now the entire margin of the ice sheet is melting all the way up to the northern extremes of it. But the real question is the melting being replaced by snow precipitation during the winter in the central part of the ice sheet? And the answer is, based on the GRACE satellites, which measure density of the ice, or the whole mass, by measuring gravity, it's clear that the Greenland ice sheet is truly losing ice. It's truly losing mass, and is probably responsible now for about 1/3 of the sea level rise that we're experiencing at this time. This is a moulin where water is pouring down a hole in the Greenland ice sheet, and that water that pours down the hole, when it gets down to the bottom, which may be more than a mile down, it will actually lubricate the ice and cause it in some cases to move faster than it was. The Antarctic, though, is the big player of all. Currently, the Western Antarctic ice sheet is probably contributing less than Greenland, but it is not related very closely. It is not necessarily related to warming temperatures in any direct sort of way. Part of the reason is because, as you can see up here, these ice shelves, like here's the Ross Ice Shelf here, and here's the Rhone-Filchner ice sheet here. These are massive floating sheets of ice, 200 meters thick or something like that. And they hold the glaciers back, and when these break up, then we anticipate that there will be a sudden surge of the glaciers that make up the ice sheet, and a sudden melting and a sudden sea level rise as a result of it. So that's one possible happening. One ice sheet up here, the Larsen Ice Shelf, did break up in 2002, but that's relatively small. The other thing is the grounding of the glaciers. Some of the glaciers are extending out onto the continental shelf, and as they begin to melt, they begin to rise up and they become ungrounded, and then start to move faster in a seaward direction. And finally, some work done just very recently by Bruce Martinson along here. He has shown that there's upwelling of warm water, which is unusual. Off here, you have upwelling, you have cold water. But this is and of course, what is defined as warm water in the Antarctic is not what most of us would call warm water. It's 1 or 2 degrees above freezing. But anyhow, there is upwelling of warm water due to changes in wind patterns, and this he believes is starting to melt the fringes of the ice all the more. So there are all these things happening that are indicating that the West Antarctic ice sheet may be the big player. This is the Larsen Ice Shelf breaking up. It actually broke up in a matter of days, but it was showing signs of breaking up for years. And it broke up, this is just on the peninsula, and some of the small glaciers that were being held up by the ice shelf did start going faster down. Well, here's the big picture right now. We believe that during the 20th century, the expansion of the ocean water was the main cause of sea level rise. And right now, at this instant, probably it still is the case. But we believe, many people believe, and there's a lot of speculation here, of course, that the Antarctic will become the big player, and Greenland the second biggest player, and and the thermal expansion will become less important. Here are some scenarios that we have come up with, that various panels have come up with. all the panels, everybody agrees that that we're going to have a sea level rise by 2100 of at least 1 to 2 meters, let's say 3 to 7 feet, something like that. And there are several estimates for California. Most of the sea level rise that is speculated on is usually around 4.5 feet, something like that, by 2100. This is guesswork, but it's based on mathematical modeling. Some of it is based on modeling, but the models have so many unknowns in them that we can't be certain. And I worry quite a bit about mathematical models, but I think mathematical models are very good at showing us the direction that things are going and giving us an order of magnitude of what might be happening. The sea level rise by the IPCC, the Intergovernmental Panel on Climate Change that got the Nobel Prize, they made a real mistake. They said it's going to rise 7 to 23 inches, and then there's going to be some more sea level rise due to the ice sheet. But they didn't say that clearly. And when I first read that part of the report, which is pretty dense to begin with, I misread it too, and I thought, gee, they're only predicting a couple feet as an absolute maximum. But that 23 inches maximum is 23 plus the ice. And then they say in their report that the ice is likely to be the major driver of sea level rise. So this is a mistake because people have taken advantage of it, or they have mistakenly quoted this in the U.S. Geological Survey in a report on sea level rise in some state or other had used this as an estimate before they reread the document. Well, as an example, in a February 2010, that's what this month is, it came out of a magazine of the Shore and Beach Preservation Association, which is an organization that's here in California too, but the Florida version of this said, and this is just an example of the skeptics and the deniers, says that they took that number that the IPCC gave and said, okay, we're going to get 1 foot sea level rise by 2100, and they say that the projection was agreed upon by hundreds of scientists. Well, that's not true. Well, it was. Yes, it is true. Hundreds of scientists agreed, but they also said this doesn't count the ice sheet. So very frustrating. And this is something that just came out a couple of days ago. Okay, what's going to happen? You all know about Bangladesh. 14 million people live below that 1 meter contour interval, and 14 million people have to move probably the next few decades. Where do they move to? One of the big problems with environmental refugees and doing something about them is national boundaries. There's a lot more room in Burma, for example, which is right next to Bangladesh, but we got that boundary, so we can't move. So, and of course, this is why sea level rise is very likely going to create major conflicts within and between nations. This is a batik, a painting on silk, so to speak, that I work with Mary Edna Fraser, a batik artist from South Carolina. And this is a batik she made of the Mekong Delta. Vietnam will have more people displaced in terms of percentage of the population and more food production erased in terms of how much the food is being produced now than any other country in the world. They have 2 major deltas, the Mekong, which you're familiar with from the war, and also the Red River Delta in the north. And these are their bread baskets and also where most of the people live. So it's a very, very difficult situation for them. This is the Arctic. This is in Shishmaref along the Chukchi Sea, and the Arctic, all the shorelines of the Arctic, including northern Canada and the 5,000 miles of Siberian shoreline, all have the same problem. First of all, the sea level is rising, so that's problem number one. And sea level is rising there about as much as it is everywhere else. Second, the beach permafrost is melting. When I visited this village, I was able to dig into the beach with a shovel, and I visited in August the first time. And a guy who was from the village said that that normally they could 20 years ago they couldn't dig a trench in the beach even during August. But now, because the permafrost disappeared, there's a lot more melt. The sand is easier to remove by waves, and then the waves are bigger and work on a longer period of time because we have much longer summers. Summers are defined as ice-free periods of time, and here in Shishmaref, the ice-free summers have expanded by 2 months over the last 20, maybe 15 years, something like that. So putting all three of these things together has created a serious problem for the village of Shishmaref, which is right there. And this is a village, this is a closer up photograph of it. This is the school here. That's the teacher's house, which they value very much. And when I visited this in winter, one time I stayed in that house there, and when I walked into the building, there were 2 dead Arctic rabbits on the floor there in the vestibule. And then walk in, and on the railing outside the front of the house, there was a caribou that was being hacked upon, caribou carcass, that is. And the toilet was a bucket. There was no running water, and there was a 40-inch television with 50 channels. So it wasn't too bad. Anyhow, you can see there have been a total of 5 seawalls built here, each one of them costing more than $1 million for a village of 450, 480, something like that. So the plan is to move Shishmaref back to the mainland. The New York Times had a big front page article on Kivalina, a village just like Shishmaref, same size, about 100 miles further north. This one's right on the Arctic Circle. And so it's going to cost, they estimate about 100 to 200 million to move this village of 450 people back. Well, why should that's $300,000 to $400,000 per person? But this is one of the very, very few subsistent, really truly subsistent villages that we have left in the United States. So is it worth doing? Why not have them move to the big city, Nome or Kotzebue, which have 5,000 people? Well, the problem is they're somewhat unwritten, but a very severe problem of alcoholism, and then these people are very skilled hunters and fishermen, but they have no skills that are useful in the big city. So don't know what's going to happen, but that's the plan. The current plan now is to spend $300,000 or $400,000 per individual. It's so costly to move a building, move a town back in the Arctic, and the government requires, and they would like to have heating, water, electricity, sewer, and the whole works, and that's very costly in the Arctic. Well, here's another group, another type of problem community. These are the atolls of the Pacific. The Maldives have gotten a lot of publicity recently. They're some a Maldive nation, an atoll nation in the Indian Ocean, and they have more than 100,000 people in there. And you may remember it was in a number of papers that they had an underwater meeting of their legislature at a depth of 30 feet. Everybody put on scuba tanks, and making the point that they recognize that they're in serious trouble. They're trying to buy land in India, or they're talking about, or Sri Lanka. Tuvalu is already moving. It's an atoll nation of 6 atolls, and it's already moving to New Zealand after having been turned down by Australia. And let's see, the Carteret atolls have moved to New Guinea. So these are the guys affected already. But the problem is not flooding. The problem is desalinization. In the Marshall Islands now, they're growing some of their crops in 50-gallon oil drums because of the salt in the soil from the rising sea and from the storm overwash and so forth. So again, it's not directly sea level. It's in this case salinization. Well, this is my home country. This is North Topsail Beach. You can see this is a photograph taken about a year ago, and this is a middle-class community, and doesn't really, this isn't our wealthiest community, but you can see that we have a condominium on the beach now, a 3-story, 4-story condominium. This house here was purchased by a couple from Syracuse, New York, right after they replenished the beach. They put in a beach, and the beach extended right out to here. So it was only about 200,000 cubic yards all the way down here. And so the couple went back to Syracuse, got their furniture, came back, and their house was on the beach, in the water, and condemned. And the real estate person who sold it knew this was going to happen, but that wasn't illegal in our state. As a result of this incident, the legislature tried to require that we put in the deed something about the fact that this property, at least say something like this property is subject to erosion, but they wouldn't even do that. But this is a far more serious problem for us. This is Figure 8, North Carolina, which is one of the wealthiest islands on the East Coast. And the problem here is that these guys are very powerful, and their voices are heard, and they're trying to overturn our regulations. In North Carolina, it's illegal to build a seawall. It is legal to put in sandbags, but they never last very long. But they're trying to, and because they're so powerful, there's a good chance that they might overturn our regulation. We feel that we don't want seawalls because seawalls take out the beaches, number one, as you've learned here in California. And number two, if you have a seawall there, you're not going to respond flexibly to sea level rise until it's too late. Well, I think I've made this point already that it's not just the flooding. It's a lot more than that. In the atolls, it's the salinization and and so forth. In the city of Charleston, South Carolina, the mayor there, Mayor Riley, who's one of the more forward-looking mayors on the East Coast in terms of sea level rise, says they're changing their stormwater runoff system because the sea level has risen to the point that the city can't drain during high tide. When they have a heavy rain corresponding with high tide, then the city gets flooded. Well, here is a ranking of cities. Now, there are many ways to rank cities and their potential and the hazard that they face from sea level rise. This is simply looking at property value of a 3-foot sea level rise when you don't do anything about it. How much property is going to be flooded by a 3-foot sea level rise? So that's one measure. And Miami tops all the cities in the world in this regard. Well, here is Miami, but Miami has another problem that makes it virtually impossible to defend. The first problem they have a mayor who denies that the sea level is rising. That's a serious problem. And then the second problem is that their city overlies the Miami limestone, which is very porous. And they have ponds within the city of Miami that you can actually detect the tides on because there's so much the water comes under the barrier islands and through this porous rock. So you could build massive seawalls along the outside of Miami, and the water would still just go right, the sea level rise would just go right behind it. So the future of Miami is an exciting one. Other community, Rotterdam, Karachi, a lot of people here, but not much property value. That's why it wouldn't show up on most of those things. This is Boston. You can see the water level down at the bottom. Much of Boston, as you probably know, is all filled in land, very low elevation. And this is Hong Kong, Lagos, Durban, South Africa, with the Queen Elizabeth coming in. What do you know? That's Tel Aviv, but it didn't work. And that's Alexandria. And this is Midtown Manhattan. Now, Manhattan holds a lesson for all of us. When Manhattan is in trouble, the question is, which is going to be more important, this row of condominiums on a barrier island in Florida or the city of Manhattan? Well, you know, this is why, except in the case of this is why we need to be studying the sea level rise now, why we need to be planning for the sea level rise now. And these guys who probably think they're going to continue to get nourished beaches from the federal government at a cost of up to $10 million a mile, there's no possible way. We have 3,500 miles of Barrier Island shoreline on the United States on the east coast from the south shore of Long Island all the way to the Mexican border. And that's going to be low priority for sure. And then we have this. What will the priority of this port, which is perhaps the most important port in the United States, certainly on the west coast, so I am quite sure that this priority here will be much higher than the rural Florida condominiums. But planning needs to be done. All ports are at exactly the same elevation, of course, everywhere on all parts of our coast. And what are we going to do? How do you raise the level of the working surface as the sea level rises? We need to be planning this now, and we're not doing it, of course. And here's part of the Los Angeles. Anyhow, here is Seattle with a 4-foot sea level rise, and Olympia. Olympia is not much of a port, but Seattle is, and the Tacoma port looks very much like that. As I say, all ports are the same elevation, so they really look about the same in terms of what will happen from a sea level rise. Of course, first thing's going to happen, the drainage is going to fail, and planning. This is had to throw this in. This is an ingenious woman on a Florida beach and along the Panhandle. I've seen a photograph something like this in California too. Here is the high tide line here. So luckily, a recent storm, took out this bunch of sand in front of the seawall. But there's more to it, and so that's where she's manages to sit. That's the only beach left that's dry. But there's more to it than would meet the eye. This beach was permitted by the state because the developer said, okay, we're going to put in a seawall, but we're going to cover it up with sand so you won't see the seawall. And of course, the sand disappeared within less than a year. And this is a flooding scene in Rodanthe, North Carolina. Nothing very unusual about this, except for the fact that this flooding occurred during a spring tide, during a high tide. And so when your islands and your roads begin to flood during a high tide, during a lunar tide, then you know that sea level rise has already arrived. This is the building that was in the movie Nights at Rodanthe or something like that. It was a terrible movie. And it has now been bought by a bail bondsman and moved. I don't know why it's important that it was a bail bondsman, but that made all the headlines. Well, I have a problem with mathematical models. I wrote a book called Useless Arithmetic, and we'll have it on display out there wherever I'm going to sign books if you want to see it. I don't have any extra copies, but I think I already stated, I feel that mathematical models are very, very useful if used in a qualitative way and if used to get directions and order of magnitude answers. But we have a lot of people in climate change who believe that models really, really work. And nature is just too complex to describe mathematically, in my view. An example of this is in the IPCC 2001 report, they assumed that the Antarctic was not going to contribute ice to sea level rise. In 2007, they said it's going to be the major contributor, probably. And the reason they didn't include it in 2001 because they had a mathematical model that said, that the warming would cause more precipitation over the continent itself. Point being that there was a mathematical model that was completely wrong, and because of that, they ignored a very important point. And we have skeptics. One of the most vocal skeptics about sea level rise is Niels Axel Werner, who has a really good pedigree, as you can see here. He's chairman of what was once a kind of a geology department, and he was head of a of a commission on sea level rise. He got fired from that, but nonetheless, he was head of it for a while. And well, you see what he's saying. He says he made a study of the Maldives, and he said that the sea level is actually dropping there. And he said it's dropping because there's a lot of evaporation in it. But that ain't the case. And this is the guy who was the policy advisor, science advisor, I think, to Margaret Thatcher. He is a very, he's got something of a sense of humor, but he ridicules those who believe in sea level rise. As you can see here, you have to think about that upper sentence. But to me, you know, this guy, it may be funny, but to me, these are they're committing environmental treason, in my view. This is unacceptable. This kind of, it's okay to make fun, but you know, because of people like this, we're delaying our planning. People are saying, don't get worried about this yet. It's not rising now. But I'm reminded of our tidal gauge that we have in North Carolina. That's on the Corps of Engineer Pier, which is a concrete pier in the open ocean. That's the best kind of pier you can get to have a tide gauge on. And at least at that point, the sea level is rising a full 1.5 feet per century, which is about what the satellites are telling us. The sea level is really rising. And, oh yeah, this guy, Scott Armstrong, he's crazy. He's come up with a list of what does he call them? Evidence-based forecasting. You have to, there's 140 requirements that you must, most of which you must satisfy to have evidence-based forecast. He's an economist. He's not a scientist, and no scientist has ever heard of this list. But he went through this IPCC report and decided not a one of them was valid. And he was the guy the state of Alaska hired to prove that the U.S. Geological Survey studies of the polar bears was invalid, and he proved it. He said they were not based on evidence-based forecast, whatever you call it, evidence-based forecasting, and therefore invalid. I think we're going to hear more from this guy, but this guy has, and he's a very charming individual, by the way, but he has this thing that he's doing that he will apply, I think, in a very broad way in the future. And this is one of many things. This is put out by the Western Fuels Association. Western Fuels, is that right? And it's by a coal group. And okay, so what do you, if you're a non-scientist, what should you as non-scientists do? How do you sort through the wheat from the chaff? And I would say that you should ignore everything that comes out of these and a number of other groups, which are easy to find out, and follow the principle of guilt by association. If anything is said by these guys, don't believe it. Doesn't mean everything they say is bad, but they are not trying to seek the truth. They're trying to seek the truth according to their own beliefs, which is not scientifically sound. So I would believe, I find at ScienceDaily.com and Cyrus.com, among others, they report articles that come out of Science and Nature and other distinguished science magazines that are peer-reviewed. And I would follow these. And yes, scientists make mistakes, no question about that. But so follow the principle of guilt by association. What is to be done? Well, I'm not going to get into that in any great detail, but I think two very important things is don't build anything next to the beach or near the shoreline or under 7-foot elevation. That's important and too big to move. And when it's destroyed by a storm, don't replace it. That's not bad ideas. This is a photograph in the tropical rainforest of Colombia, on a barrier island in Colombia on the Pacific coast, and it shows them moving a house. These houses here, there's absolutely zero government support for this island, for anything, education, malaria, eradication, nothing. And so, but the houses are built out of panels, and once And at the moment this photograph was taken, the shoreline was eroding at about 1 meter per day. The problem was the land had sunk in a recent earthquake, and so it was going back, truly going back gangbusters. So once they got the pilings put into the house, 2 men can move and reconstruct the house, they told us, in about 2 weeks. So that's the kind of house we need to have more of. If you can't do that, then you can do this. Done in 1888, and this is the moving back of the Brighton Beach Hotel in Coney Island, New York. And as you can tell, you might guess that this hotel is owned by a railroad company. At any rate, so it can be done. This is an 1888 drawing, I think, from Scientific American, and the earliest example of moving back that we know of, but we didn't really make a study of that. A graduate student of mine's father was in the dentist office, and he found this photograph, and that's how we know about it. And this is, the last photo, is this Morris Island, South Carolina lighthouse, which is 4,000 feet in front of the shoreline of Morris Island, and it was built, no, it's 1,200 feet, 400 meters, something like that, in front of the island, and it was built 400 meters behind the island in the original lighthouse was destroyed when the Yankees attacked this island, and they built this in 1880, something like that. So it has a foundation of 35 feet deep, and the waves here are fairly calm. Well, this is a very extraordinary calm day here, but the Cape Hatteras lighthouse, which was moved back 2,000 feet, had a foundation that was only 6 feet deep. In fact, the base of the foundation was above sea level. And the waves are much more energetic, so it had to be moved. Anyhow, I would hope that we will see more of these kind of photographs, or maybe more of the moving back of the lighthouse. If you can move a lighthouse back that weighs 3,500 tons, we can move a lot of other things back. I haven't gotten a chance to really talk about some of the differences between the Pacific and between the West Coast and the East Coast. In terms of monetary concerns, the East Coast, because of all the cities that are built on the lower coastal plain, there's more property damage potential there in terms of flooding, because so many of the cities are so low. But the damage here, especially in terms of port and other infrastructure here, is extremely severe as well. Potential is extremely severe as well. And I quit. I stopped.
Yeah, it's a fairly simple question. You have these different projections of sea level rise, say 1 meter or maybe 2 meters by the end of the century. And just assuming linear rise, you could make a whole fan of possibilities, and each one would be associated with certain cost if we follow your advice and start building and moving and so on. Has anybody done that? Has anybody worked out just what the cost of that kind of adaptation might be?
Not really. No, I mean, that's why I'm saying we need to plan, but not really. Nobody's really done a nitty-gritty thing. These estimates that I showed up there were done by panels, by state panels. You have several in California doing this, which I'm sure you're aware of. The best one, I think, so far is one in Miami, which, of course, is a city that doesn't believe in sea level rise. So, but no, that's the next step, and that has not been done. In fact, I have not heard any study done of what we're going to do about the world's ports. In fact, I could expand. I said all American ports are the same elevation. Well, all the world's ports are exactly the same elevation, so they all we have to do something. Are they going to be floating platforms? No, the cost, as soon as you start getting into figuring the cost, you immediately run into, well, what buildings are we going to save and what buildings are we going to, it becomes so complicated and so political. But we need some panels, and I think California is starting to do this. They're not there yet.
The ports of Los Angeles and Long Beach and the Port of New York, New Jersey have entered into a contract with the Rand Corporation to do the kind of study that you've talked about. And they've got one other port, now I've forgotten which one it is, that's part of this consortium. And as Orrin says, these things are beginning to be looked at. And the first step is people are looking at, with a certain sea level rise scenarios, how much infrastructure is at risk. What will be the economic losses?
Now that we have done.
That one, yeah. And the next step then is to what will it cost to for strategic retreat, and that's just beginning.
But even looking at that, how much damage is going to be caused by flood? You know, Holland's a very rich country. Bangladesh is not. So Holland's going to do something about it, and Bangladesh isn't.
And in California, the Pacific Institute did quite a good study on the effects of two different sea level rise scenarios. And on the ocean coast, the two counties that will have the greatest losses will be Marin County and Orange County. And the area that would be at greatest risk is San Francisco Bay. But on the ocean coast, it's Marin and Orange. And they've done quite a good job of looking at the number of the value of homes, hospitals, infrastructure, etc.
Number of garbage dumps or landfills. Boy, the 330 landfills in California that will be flooded with a 3-foot or 4-foot sea level rise.
I was wondering what you think about the restructuring of New Orleans. Is it safe now that they rebuilt those levees? And what about hurricane impacts as well as the sea level rises on cities?
Well, regarding the second question, really what's at least on, well, here too, the thinking is all about what a 100-year flood, what a 100-year storm is going to do. It'll be the storm that'll do the damage. It's not going to be all the time that the sea level is rising, there are storms. And each storm brings it up a little bit more. And it's going to be that storm that's going to do the damage. It's not going to be the flooding per se, very likely. And that's what much of the thinking in the California report that I've seen are the 100-year storm.
I think I know a little bit about the port, and I can picture what the port's going to do. They're just going to bring in more dirt and raise the level and probably have the money to do it, at least for a while. But what is going to happen in Miami? I mean, are people going to live on the upper stories? Are they going to try and create islands out of various buildings? I mean, realistically, where are those millions of people going to go?
I didn't say they have it. I mean, basically, Miami's an island. I mean, they have the Everglades, which is coming up as well behind it. All this in this porous Miami limestone with a mayor that doesn't believe in sea level rise. You put it all together, and I don't know. Maybe there's an engineering solution to the porous limestone of grouting the limestone to it. It must be hugely expensive, but I think it sounds impossible. I think it's. If I was living in Miami, I think I'd sell off right now, get out of there. But everybody can't do that, so I don't know how to answer that. To me, it looks really, very, very serious.
It's really happening in Long Beach, and people might not realize it. 1993, we had a series of storms, and my car was parked at the corner of 10th and Bennett, and my car was underwater. And if you saw the photos of the last storms, that same corner was inundated 17 years later, and the cars were underwater. But I think there was more flooding this time, and it's, as you say, the storm is the trigger. And it was much worse because the sea level rise is up there underneath the land. And we're all going to be seeing the results. And of course, anybody living in Belmont Shore, Claremont Avenue gets flooded every time there's a high tide now. It is coming.
A real quick comment about one thing. It's much more complicated. Sea level rise is much more complicated on this coast than on the East Coast because you have variable amounts because of the movement of the land. And in Crescent City, the sea level may be at this moment going down, I think. But that's the only place it's coming up, but at different rates. So, excuse me.
Dr. Pilkey, it's a pleasure that you're here and a pleasure to hear you. I'm curious from your previous book, Useless Arithmetic. You took a number of modeling communities to task. Are you Do you view any modeling communities more dangerous, say morphology modeling, sea level rise modeling, predator-prey type modeling, fisheries modeling, more dangerous than other communities?
I do have a difference of opinion. I think there are different professions take their modeling with different degrees of seriousness. Groundwater modelers believe everything, and coastal engineers believe their models. But a lot of other modeling people, fish modelers, for example, and others, they realize that they're getting making a good educated guess. Or as one of my friends says, they're looking at the digital back of the envelope number. But it's and if you look at it that way and keep that in mind, but some of the climate modelers really believe their numbers too, and you know, we're hearing numbers like at a certain number of CO2. When it reaches a certain point, there's no turning back. Well, maybe there is that point, but who knows what that point really is. And so, but you can buy the book. It's $20 or something like that. It's a pretty skinny book for $20. But.
I have to put in a good word, though, for models, because models can, when used properly, do things that we can't do in any other way. They allow us to synthesize the state of our knowledge, to incorporate different data, and they tell us where the weak points are in our science, the next questions to ask. And if you look at what they've contributed, for example, to in hydrodynamic modeling, coupled hydrodynamic and water quality models for estuaries and so on, they have allowed us to do things that we could never do.
Yeah, I think models are extremely good for using huge amounts of data. You can't do it any other way. And also for looking at what-if questions, why questions, how questions, but not where, when, and how much questions.
You showed one graph of the CO2 rising.
Yeah.
And that was it?
Yeah.
Are you trying to say that CO2 rising is the cause of the rising of the water?
Well, the indirectly, CO2, I would say that CO2 increase is responsible in part for increase in temperature since the 1970s at least, 1960s perhaps. You start getting back further than that, you start getting into solar radiation variations and all kinds, the Milankovitch angles of the Earth and so forth. But I feel very confident from the literature that CO2 is responsible for the increased temperatures, which is responsible for the melting of the ice and the warming of the ocean, which is raising sea level.
If you like Orrin's book on useless arithmetic, if you haven't read How to Lie with Statistics, I recommend it. How about a nice round of applause for Orrin Pilkey?
Thank you very much.